Index actually enforces business rules and it improves performance. However, selecting where by key column is null cannot use the index and will therefore always result in a scan of the entire table. Okay, that's not a big deal. So guys, which one do we talk about? Unique constraint. Unique constraint is just a constraint that doesn't allow duplicates, but it can allow null values. Then let's talk about the not null. Not null, which you're going to see written like that. Not null constraint. And the unique constraint, you may just see it written as a U somewhere. So when they say something is not null, what in reality does that mean for us? So guys, not null in reality is equivalent to mandatory. Means you must do something. They call this mandatory columns. The mandatory column. The not null constraint forces. So guys, let's read this one. That one forces values to be entered into the key column. Not null constraints are defined per column. So these things are defined per column and are sometimes called mandatory columns. If the business requirement is that a group of columns should all have values, you cannot define one not null constraint for the whole group, but must define a not null constraint for each column. Okay, maybe that's a good idea. Yeah, in that whole thing. Any attempt to insert a row, so guys, any attempt to insert a row without specifying values for the not null constraint columns result in an error. It is possible to bypass the need to specify a value by including the default clause on the column when creating the table. Okay, as discussed section. We're going to talk about that too later. So guys, so that is our number 2 type of constraint. This one up here was number 1. Let's talk about the third one that everybody should know, called the primary key. So the primary key constraint is the means of locating a row in a table. So guys, so primary key constraints are used to locate rows in a table. The relational database paradigm includes a requirement that every table, so guys, every table should have a primary key, namely a column or combination of columns that can be used to distinguish every row. Oracle database deviates from the paradigm and do some other RDBMS implementations by permitting tables without primary keys. So guys, normally the one in a relational database, every table should have a primary key, but not necessarily. Let's talk about the next line. The implementation of a primary key constraint is in effect the union of a unique constraint and a not null constraint. This is that part that we talked about. A primary key constraint is union of unique constraint and not null constraint. In other words, people, what they're saying is this. What it's saying is that the primary key equals the unique constraint, or let's call it unique key, plus not null. That's what the primary key constraint is. Cool. Let me see how much of this I should read for you guys. The key columns must have unique values and they may not be null. Catch that. So the key columns may not be null. As with unique constraints, an index must exist on the constraint columns. So guys, you want to create a primary key, that index, no, that column must have an index. Otherwise, Oracle will create one implicitly. If one does not exist already, an index will be created when the constraint is defined. A table can have only, this is some example, this particular idea here. A table can have only one primary key. So guys, I want to put a star near this one just so you remember it. A table can have only one primary key. Try to create a second one and you have an error. A table can, however, have any number of unique constraints and not null columns. So if there are several columns that the business analysts have decided must be unique and populated, one of these can be designated the primary key and the others made unique or not null. An example could be a table of employees where email address, social security number, and employee number are all required and unique. Who really cares about that? Let's see the example here. Unique and primary key constraints need an index. Yes. So guys, let's just need an index. So guys, so these two keys, the unique constraint, the primary key constraint, they all must have indexes to work. Now let's go to number 4, I think. Yep. The foreign key constraints. So guys, the foreign key constraint is defined on the child table in a parent-child relationship. So guys, catch this. Parent-child relationship. The constraint nominates a column in the child table. We highlight this. So guys, the constraint for the foreign key, right, nominates a column or columns in the child table that corresponds to the primary key columns in the parent table. The columns do not need to have the same names, but they must be of the same data type. Foreign key constraints define the relationship structure of the database. So guys, catch this. It is the foreign keys that actually define the structure of our databases. That is the many to many. So guys, there is many to one, relationship that connects. So what does this thing do? So that connects a table in their third normal form. And so what here that I'm going to put, you guys can research that a little bit. Something called third normal form. What is the third normal form? Something was known. Okay. If the parent table has unique constraints, as well as or instead of a primary key constraint. These columns can be used as the basis of foreign key constraints, even if they are nullable. See another exam tip. So close. When you see them so close, know that they're important, guys. A foreign key constraint is defined on the child table, but a unique and parent key constraint must already exist in the parent table. So guys, talking about the parent table and the child table. Let me see, what else? Yeah, this is an important part of the book, so that's why I'm going through it. And I would also recommend later on, guys, look at this, look at this, look at this. Foreign key. Okay. There's something about orphan roles that we'll have to talk about. So let's start reading from this section here. Last paragraph here. Just as a unique constraint. So guys, talking about that unique constraint. Is it just that unique constraint permits null values in the constrained column, so does the foreign key constraint. You can insert rows into the child table with null foreign key columns. Even if, next page, there is not a row in the parent table of that value. So guys, and we are told, when you do this, this creates something we call orphaned rows. I want everybody to kind of mark this in their book. We need to kind of have a good idea of what these orphaned rows are. What are orphaned rows? It can cause dreadful confusion. Hey guys, as a general rule, let me just finish this. As a general rule, all columns in the unique constraint and all columns in a foreign key constraint are best defined with not null constraints as well. This will often be a business requirement. Now, guys, let me zoom in here. From the reading, I want everybody to read back the line before the word orphan rows, and let's all see if we understand what orphan rows are. I'll give you guys a minute. Everybody read backwards, or go back one line. I want to see if you guys understand, if you guys can find out what an orphan row is. When they say a row is orphaned, what does that mean? Thirty more seconds. 30 more seconds. Right back. Anybody? What's an orphaned row?
In a lay sense, Prof, it's like since the node null is not in the parent's table, it's like it does not have a parent. It does not, that's why it's an orphan, because it's found only in the child null constraint column.
Yes, that's all it is. We talk of a parent table and a child table. Every row in the child table should have a corresponding primary key value in the parent table. But if that is not true, and you have rows that don't have corresponding rows in the parent table, then that row in the child table is an orphan row. That's the whole idea. Guys, who needs that explained again?
So please explain again.
Okay, let me get Jacques-Claude. I want you to try to explain that. What is an orphan row in a database? Are you there?
Yeah, sorry. What's the question?
What is an orphan row in a database?
That's like think a row in a table that's related to, I guess, a row in another table that used to exist but doesn't exist anymore.
Kind of. Hey guys, if you remember, we created a table called student and a table called class. If the student table is the main table that every student in the school has their name on it, that's the admission table. Then out of the admission table, they're going to make the different classes. So for your name to be in a class, you must exist in the admissions table, which is called student. But if we have, for some reason, we have some students whose names are not on the main student table or the registrar, those students are orphan students. That's what it is. In other words, rows in the primary key, in the foreign key table that don't exist in the primary key table. Because the table, the primary key is the parent table. The table, the foreign key is the child table. Okay, let's move on. Let's move on. So guys, attempting to insert a row in the child table for which there is no matching row in the parent table will give an error. Similarly, same thing guys, try to delete. Deleting a row in the parent table will give an error if there are already rows referring to it in the child table. There are two techniques for changing this behavior. If you want to change that behavior, there are two ways you can do. First, the constraint may be created with. So guys, we can actually create a constraint with onDelete cascade. Okay, you can create a constraint with onDelete cascade. What does that mean? This means that if a row in the parent table is deleted, Oracle will search for the row, for all the matching rows and delete them also. That's in the child table. Oracle will search the child table and delete all matching rows. So if you create a constraint, right, and you say onDelete cascade, means if you delete a row using that no, a row that has to do with that constraint. On delete cascade will search for rows, for those particular rows in the foreign key or the child table and delete them for you. On delete cascade. And they said this will happen automatically. A less drastic technique is to create, so less drastic technique is to create constraints as on delete set null. So when we do set null, what we're saying is, in this case, if a row in the parent table is deleted, Oracle will search the child table for all the matching rows and set the foreign key columns to null. See, we'll not delete them, but it's going to set them to null. So part of the data in the foreign key columns will be set to null. But the entire row, the rest of the row will still exist. And it says this means that the child table rows will be orphaned but will still exist. If the columns in the child table also have a not null constraint, then the deletion from the parent table will fail. Guys, why would it fail? Because there's a not null constraint somewhere. It is not possible to drop or truncate a parent table. So guys, this is something you'll see in your Oracle exams. This one here, that it is not possible to drop or truncate a parent table in a foreign key relationship, even if there are no rows in the child table. This still applies if the onDelete set null or delete cascade clause are used. So guys, you cannot, if I create a table and I have, it's a primary table and I create it's a primary table and I create a child table for it. In other words, parent table, child. You cannot delete the parent table, drop the parent table if the child table exists. You must first of all break that relationship between the two tables before you can drop the parent. Okay. A variation on the foreign key constraint is something we call the self-referencing foreign key constraint. What is that? They said this defines a condition where the parent and child row exist in the same table. Guys, catch this. They say the parent and child row exist in the same table. An example is a table of employees. This is a typical example that I see even in exams, okay? That a table of employees that includes a column for the employee's manager. The manager is an employee and must exist in the table. So if the primary key is the employee ID column and the manager is identified by a column manager ID, then the foreign key constraint will state that the value of the manager ID column must refer back to a valid employee ID. If an employee is his own manager, then the row would refer to itself. Okay, don't worry much about that. That's just some typical example. So let's go down to number 5 constraint. So guys, it's called the check constraint. Just before I get in it, I will let you guys know again, the check constraint is simply that constraint where you go to, you're filling a form and you see that there are values and you just have to choose one. You can only choose one from the given values. That's a check constraint, very simple. And they call it list of values. You check one from the list of values. So A check constraint can be used to enforce simple rules, such as the value entered in a column must be within a range of values. So guys, that's it here. Range of values. The rule must be an expression that will evaluate to true or false. The rules can refer to absolute values entered as literals or to other columns in the same row, and they may have used some functions. As many check constraints as you want can be added. You could put it as many as you want. Can be applied to one column. But it is possible to use a subquery. No, but it is not possible to use a subquery to evaluate whether a value is permissible or use a function such as C. Don't worry about that. Now, guys, the not null constraint. Not null constraint. We see that that one is in fact implemented as a pre-configured check constraint. The not null is kind of like a pre-configured. It's a check constraint. Cool. So those are the 5 important constraints. The rest we don't care about. Now let's talk about how you make constraints. How are they defined in a database? So here, guys, you can do these things. Constraints can be defined when creating a table or added later on. You gotta make your choice. Which one do I want? Okay. When defining a constraint at table creation time, the constraint can be defined. Oops. Get a pen here. Can be defined in line with the column to which it refers, or at the end of the table. So guys, let's say constraints can be defined in line or at the end of the table definition. There is more flexibility in using the latter. Guys, what does the latter mean in this case? Who's awake with me? Boring class.
Latter simply means when there are two, you mention two things. The second one is always the latter.
Okay. Good. Like one that is late. For example, it is possible to define a foreign key. Let's do this here. Let me highlight this. Now, it is possible to define a foreign key constraint that refers to 2 columns or a check constraint that refers to any column other than that being constrained if the constraint is defined in line. But both these are possible if the constraint is described at the end. Okay, let's go make these things. It's more practical than anything, guys. All the theory, and if you don't remember it, I want that you must know how to create constraints. Defining constraints. Okay, guys, for constraints that require an index, remember, some constraints you must use an index. Unique and primary key constraints. So, guys, so these are the 2 that require an index. Unique and primary key constraints. The index will be created with the table if the constraint is defined. A table creation time. So, guys, so you create a table, and during the creation, you declare an index. No, you declare a constraint the index will be created for that constraint for you. Consider these two table creation statements to which line numbers have been added. So guys, let's see this thing here. It's a long, little complex thing here, but we can do it. So guys, see the first one, create table. Table is debt, right? And then, whenever tables are created, I want you guys to watch something I didn't point out in the other one. You start them with open parentheses, and you must end with an open parenthesis down there, 1. That's how they start pairing those parentheses up. Okay? Now, after you put your open parentheses, you start to give your column names. Very simple. So if you look at this particular one here, the column name is department no, and the data type is number 20, and the constraint, guys, I want you guys to take note here. The constraint has that name. That's the name of the constraint. Depth underscore depth no underscore PK. See, they use PK here. Guys, I want you guys to pay attention to these names. He used PK here to match it to primary key. You see? And then, watch here. The name, depth, because it's on the department table, and the column is department number. That's how come name it like that. Okay? Then let's see, there's another constraint coming down again. So there's constraint, and this constraint now is a check constraint. Just 1 second, let's see if I can code this for simplicity of it. So the next one is a check constraint, and see how it is named, guys. It is named like that because it is a check constraint. So guys, check constraint. And guys, notice the check constraint. The thing is, department number will be between 10 and 90. So that's a typical check constraint. They're using numbers, okay? Then let's see the next one, D name. That's department name, right? VACA 20 constraint. And the constraint here is a not null constraint. Because it's a not null, that's why I have them put this and N at the end. Cool. Then later on the create table employee, right? And they give some more things. So guys, let's just look at this last one, then we can almost begin to get to the end of the day. People watch this. Create table EMP. EMP number 4. And they give it a constraint. And the constraint name will be that, and the constraint type. That will be type. I want to be name. Then guys, let's see how you do a foreign key. We haven't seen that yet. So guys, look at the second column here. Second column here is e-name. And e-name, VACA 2, constraint, that one is a not null constraint. Yep, that one's a not null. And then manager. So let's go to the next one, manager. Constraint, references, EMP. So guys, I want you guys to watch here. So they take the manager and they're creating a foreign key with. How do I know? From the name. Guys, watch that. Naming is very, very important in this whole thing, okay? Naming is so important. But when they say reference here, then they give that. That's a table. So they're referencing that table. And in that table, they're dealing with that column name. Right? And there's another foreign key here. Guys, we're going to look at this later on and create our own, okay? Then there is a check constraint down here. And notice the check constraint. The check constraint there is looking at higher dates, greater than or equals to your date of birth, plus 365 times 16. Whatever that is, right? And then there's email. Where is that? Yeah, email. And we're using a check constraint. Cool. Anyway, so I want you guys to do this for me at your own pace when you are really free. I want you to read this. When you're reading that, you're taking this into account. All of these things here. Okay? That's the explanation down there. Let's don't go through that. Let's get to somewhere where we can do something hands-on. So this whole thing is better when you do it hands-on, then it will make much, much more sense, okay? So let me see where we're moving to. Was this an exercise here? No. Okay, this here just explaining that whole thing up there. Okay, let's look at something here. It says the preceding example shows several possibilities for defining constraints at table creation time. Further possibilities not covered include. But I want to just look at some of these because we're going to see this as we go in to work. Controlling the index creation for the, yes. So guys, we could actually control how the index is created when we create a constraint. Okay, we can actually do that. In real production, that's what they wanted to do. The second one, defining whether the constraint should be checked at insert time, which it is by default or later when the transaction is committed. The third one, stating whether the constraint is in fact being enforced at all, which is the default. Okay, let's go to states of a constraint. After I create a constraint, right, the constraint can be at different states. Just as when we created a user, we find out that the user can be at different states also, and even a profile and all those things. But for a constraint, let's see, at any one time, guys, every constraint is either enabled or disabled, valid or not validated, or rather validated or not validated. Any combination of this is syntactically possible. You can have any combination of that. So let's see here, guys, when they say a constraint is valid, guys, what's that? Valid, no, enabled, valid. In other words, it is enabled and it is valid. What does that mean? That is the number one. And actually, this is the default behavior of constraints. So, one being enable validates. Let's see what we should know about this particular one. They say it is not possible to enter rows that will violate the constraint. and all rows in the table conform to the constraint. So guys, if you have your constraint at the state of enable validate, means it is working. It is taking effect, doing what it's supposed to do. And the next one, disable no validate. So the constraint, guys, listen to this, means the constraint has been disabled and it cannot validate data. So let's see what that means. Any data coming, let me see, conforming or not, can be entered, and there may already be non-conforming data. In other words, guys, disable no validate simply means the constraint is disabled. If it is disabled, then there's nothing to validate the data. Okay? So data will just come in. As long as you can fit in the table, you can just put it in because there's no constraint controlling it. So that was number 2. And number 3, enable no validate. What is that no thing there? Enable no validate. And that particular one, we are told here that there may already be non-conforming data in the table, but all data that entered now must conform. Enable no validate. In other words, guys, the no validate is for the data already in the table. Means that data has not been validated. But once you enable a constraint, it is now reinforcing what it's supposed to do. So enable no validate means the data that is already inside the table, don't worry about it. But any data coming in now, we have to check that data for accuracy. And number 4, disable validate. All data in the table conforms to the constraint, but new rows need not. The index is also dropped on the constraint. So if you do disable no validate, you actually drop the index. But most importantly, guys, data in the table must meet up with the criteria, okay, or must conform with what the constraint wanted to do or to be like or to look like. Okay, the index is also dropped. Okay, we don't care about that. Okay, the ideal situation, guys, and the default when a constraint is defined is enable no validate. This will guarantee, so guys, with that is guarantee that all the data is valid and no invalid data can be entered. And the other extreme is disable no validate. So if we have that disable no validate, what does that mean? So this one can be useful when uploading large amounts of data into the table. It may well be that the data being uploaded does not conform to the business rules, but rather than have a large upload fail because of a few bad rules, putting the constraint in this state will allow the upload. In other words, guys, you have 1 billion rows to load, right? And maybe 10 rows are not in correct order. But you need to load. You don't have time to waste. At that point, that is when you're going to do this enable no validate. And then you load your data. After you load your data, then you can validate the data. Of course, before you do that, you have to clean the database again, right? Take out rows that don't conform. Okay, let's go down and down and down to the next section. Let me see. Constraints. One of the boring sections, but guys, just bear with this one. Disable no validates. Oh, there's something I should highlight here, guys. That immediately following the uploads, transition the constraint into enable validate states. But I want you guys to, I want us to take a pause here for something. Here, see this thing here, that's a large load. Disable no validate. I want somebody just circle this and just write some little thing about it. When do we use this one? This guy is useful when doing bulk data. The bulk data load. Of course, it's into the database, right? So if you want to import huge amounts of data, you can disable no validate all your constraints. Okay. Let's see if there's another thing. Let me see. Did I ever do this example here? Okay, let's look at some example down here. The second chapter, the second section from the top or paragraph. Say, as an example, consider this script, which reads data from a source table of a live data into a table of the archive data. The assumption is that there is a not null constraint on a column of the target database or target table that may not have been enforced on the source table. Let's see if this is the example here. So guys, okay. Alter table. We have done this kind of alter thing before, right? Alter table sales, modify constraint. That means we want to change the constraint. And when you do that modify, now we say disable no validate. That's why you put one in that state. You see that? Then after we do that, now we proceed to doing some insert. Insert into sales archive. Select star from sales current. Alter table sales archive. No. Alter table sales archive, modify constraint. Enable no validate. Then update sales archive, set channel, channel is null. Then at the end, we do enable validate. Okay, don't worry about this, guys. You'll not see this. I think I've done something like this just once, but it took a lot of time to research it. So forget about that, guys. We've seen 5 constraints, right? Now we need to find out how do we check on constraints to make sure they're doing what they are supposed to do. So that's an important thing for us to talk about now. So constraints, guys, can be checked as a statement executed, an immediate constraint, or when a transaction is committed. In other words, guys, when you execute a statement, the constraint can fire up right there. Or sometimes you may decide to say, let the constraint only do something after the commit has done. And normally when you are doing something like that, means the constraint that you design is called a deferred constraint. Means it doesn't act when your data comes in. It acts after you have inserted your data and committed. So those ones are called deferred constraints. By default, let's see the default here. All constraints are immediate. and not deferrable. An alternative approach to the previous example would have been possible had the constraints been created as deferrable. So guys, so you create a constraint making it deferrable. That means it will not act until the data came in, and the data comes in and it's committed. So if we ever have to do that, let's see here if this makes sense to any one of us. So we do set constraint, deferred. See, that's how we set a constraint deferred. Then after that, they did some insert from another table. So guys, watch here. They're loading data from another table. Then they do an update after that. So there's an insert, there's an update. Then we're updating that data. So update sales archive, set. What are we setting? We're setting channel 1 equals not known. Where channel is null. Okay. Then they do a commit. Oh, we all remember what commit does. Then after that, we set our constraint now back to immediate. So this whole section just tells us how we can change the state of the constraint. That's all it is. Okay? That's all that this one is. So I'll put a little star here because I know this is the only place in the whole book, the whole course that will see this thing. We're not going to see it again. Let me see if there's any other thing we need to talk about. Oh, yes. Oh, yes, guys. Boring, but we got to go through this part painfully. If I could skip this, I would skip it really, really quick. So the book says, guys, for the constraint to be deferrable, it must have been created with the appropriate syntax. So this is how you create a deferrable constraint, guys. So we do that by doing alter table sales at constraint. Alter table sales at constraint. Give the constraint name. Then you define the type here. And you just check. And they say it's not null. Or channel is not null. That's not the important thing. The important thing is this one here. Deferrable initially, immediate. Okay, let's see here. It is not possible to make a constraint deferrable later. Are you sure? If it was not created that way. The constraint, SANNI, will by default be enforced when a row is inserted. But the check can be postponed until the transaction commits. That's true. That's the whole purpose of referable. Highlighted too much. Just 1 second, guys. Good. A common use of deferrable constraints is with foreign keys. Guys, let's pick this up. The foreign use of deferrable constraints is with foreign keys. If a process inserts or updates rows in both the parent and child table, then if the foreign key constraint is not deferred, the process may fail. If rows are not processed in the correct order. Okay, don't worry about that. Changing status of constraints between these guys. No validate. It's an operation that will affect all sessions. Okay, don't worry about that section there. And the last thing here says the status change is a data dictionary update. Switching a deferrable constraint between immediate and deferred is also specific, though the initial state will apply to all sessions. All right. By default, guys, constraints are enabled and validated, and they are not deferrable. Some exercise here for us to manage constraints. You guys, I'll do this exercise like 3 times. Let's see if there's anything. Oh, let's talk about something new before we go. We got 10 more minutes. Hey, guys, whatever. So we finish constraints. That's it. But we need to use them, then we'll understand them, okay? But I know right now if you shake your head, you may remember nothing about constraints. That's okay. But don't let 24 hours go without you just browsing through the notes again. What is a view? Let's talk about views. Views are an important part of the database, believe it or not. So important that we cannot do without them. Views. A view, guys, is nothing but, I think we created views already in this class. I remember giving you guys an assignment of one, and I did it. So, everybody just write down views. Let's just take some few facts about views. Just in other words before we go reading. So the first thing is views. These things are named. What are they? Named select or named queries. Let's zoom in a little bit. They are named select statements. Or queries. On, guys, they are on something. On a table, it can even be on a cluster, and or views. We write a view on a view. Cool. Let's see the next point that I could like you guys to remember about views. That one would be views have no data. The views have no data, have no data of their own. Okay, views have no data of their own. Next thing about views. Views show or display. Or let me use display. The views display data from tables, other views, etc. Those are the 3 main points we could know, and I almost skipped this little introduction here. So, to a user, a view looks like a table. In other words, a two-dimensional structure of rows, of columns against which the user can run select and DML statements. The programmer knows the truth. What is the truth that the programmer knows, guys? That a view is just a select statement. Any select statement can return. Now, any select statement returns a two-dimensional set of rows. If the select statement is saved as a view, then whenever the user query or update rows in the view, the statement runs and the result is presented to users. In other words, guys, very simple. A view comes from a table. It has no data of its own. But you write the query and it works, you create a view out of it. So every time you query that view, you're actually running that one query that you kept. That's the whole idea here. And coming down a little bit, say the select statement on which a view is based can be anything. It can join tables, perform aggregations, or do sorts. Absolutely anything legal select command can be used as the basis of a view. So guys, views are nothing but queries that have been saved and given a name. Views share the same namespace as tables. That means, guys, you cannot have a view with the same name as an existing table. Anywhere that the table name can be used, a view can be used, yes. So, let's see, we got a few more minutes. Why use views at all? Why do we use views? What are the importance of views? Why do we use views? So guys, everybody should write this in the top of their book, which should be uses of views. Why do we use views? Uses of views. And for the uses of views, we're going to find them all down here. So guys, down here, possible reason include security. So views provide security. Next thing is views would simplify the use of SQL statements. And views, we use them will prevent serious errors. And improving performance. And the next one would be and making data comprehensible. So how many are those? So guys, if I have to list them, I'll say possible reasons include number one, providing security. And number two, they simplify SQL statements. And number three, views prevent errors. Okay? Could use that to prevent errors. And number four, improve performance. Then number five, making data comprehensible. We can use views to simplify our data, like the $$ tables, right? Or the DB underscore tables. They actually come from some huge tables. But Oracle thought it wise to simplify them and give them to us in 3 different groups. User underscore, all underscore, DB underscore, right? And of course, the one for CDB. Okay. Guys, those are the 5 reasons for using views. And now we can go down here and read the details, which I will let you guys read later on. I will not go reading this whole thing again. It wouldn't make any sense. So, The number one reason is you could use views to enforce security or to provide security. That's what it is. Okay? And that one, because it may be that users should see only certain rows or columns in a table. There are several ways to enforce this, but a view is often the simplest. You can do that with many things, but views are the simplest. Consider HR employee. This includes Okay, I won't go reading that. But guys, let's see down here how you can do that. Guys, watch here. Create view. Oops, create view. That's the name of the view. HR IMP underscore fin. Okay? That's financial, I think. As then they give us the whole query. So the big thing about view is this, guys, that this query here must be a valid query. Means we have tested it on its own and it worked. Okay? Then we can create a view out of that. Let me see. Let me see here. I want you guys to watch something. Oh, let's read here. Note that the use of schema qualifiers for the table as the source of the data, often referred to as either the base or the detail table and the view. Guys, watch carefully. Let's go back to the top right, to the query. Look at that query. Select hire date, job ID, commission percentage, department, from. Right, this is the schema name. This one is the table. So here, what it's telling us is that if, oh, same thing over here, forget to also show that. So that's the schema name. And this one is, that's the view name. So if you do, guys, watch here, create view, hr.empfin. We are saying that no matter who run this this view, right, is going to create that view to HR. And the view must be called that. In other words, this is just an explanation of why we append the schema name to the object name. It's just to emphasize that that object belongs to that schema, okay? Let me see if there's another thing for me to explain here. I would just put here, read, not much for us to keep discussing here. But by the way, just 1 second. Let me, if I really leave this section. I saw a word here that I did not emphasize. So guys, there is this word here, base or detail table. That's a base table, right, is the table on which we are writing the select statement that's creating our view, okay? We call it the detail table. I say this just so that if you ever go anywhere and you hear of a base table, a detail table, you better know that it's nothing but just a table on which we have created other tables or views, typically views, really. You call that table a base table, okay? And for security in this particular section, right? Say for security, it's like this. We have a table called employees. It has all the employees table. And we need our secretary to be able to use this information in our database to correspond with the workers, right? So we need to give that secretary only some information. We don't have to give them all the table to view everything. So we'll create a view in this particular case. You see, they created their view had higher date, job ID, salary, commission percentage, department ID, and then that's it. Maybe they'll skip things like social security number, date of birth. They'll skip all those other kind of things. They will not be part of the view. It means we are securing our data. We don't just want anybody to see the data. Just anybody. It should be specific people. So any new person that comes or group and they need to see the data, we're going to write a view to give them just what they need. We don't give them much more than they need. That's the whole idea. So another thing is our number 2 here, right? So you can use views to simplify user select statements. It's also a very simple concept here. And the whole idea is this, guys. We don't want, not just, as a matter of fact, not everybody can write complex queries. So if we know that, we can now do our database, right? We'll create views where people are supposed to write some complex queries. We'll give them a view. And they will not be there writing some wild queries anymore. That's the whole idea of that. Let me, just a second. What's important here? So let's highlight a few things here. It will be much easier for users to query data if the hard work, okay, such as joining and aggregation, is done for them by the code that defines the view. If in the previous example, the user had to write a code that joined EMP, fin, view, and departments table, and sum the salaries per department, this could be done as a view. So guys, so just create a view, and you create view, give the name, then we put our select statement. See, this is one query here. That's one wild query that not any person can write. Only somebody who understands the business, understands the tables, and knows how to write SQL can write that. But after they write that, and we create a view with it, forever we will just query that view to get all of that data. That's the whole idea. So using this view, we have simplified how to query, how to write that whole query by transforming it into a view. Okay? That's the whole idea. Views to prevent errors. Same thing. Not everybody can write views, right? So what we do is, well, not everybody can write complex queries. So we take the complex queries, convert them into a view, and then just give it to people, and people can just do select star, and they'll see all the data. Let me see if there's anything more. Just 1 second, guys. Okay. Yeah, let's just highlight a few more things here. And, whoa, 7:37. Let's just finish importance of views, then we can close for the day. So guys, it is possible to prevent users from making errors, but well-constructed views can prevent some errors arising from the lack of understanding of how data should be interpreted. The preceding section already introduced this concept by constructing a view that will list all departments, whether or not they currently have the staff assigned to them. Then below here, they say a view can help to prevent data. A view can help to present data in a way that is unambiguous. So, in other words, guys, we know what anything that's ambiguous, something that's confusing. So we do create table. I don't have to go through that syntax. Let's go down. Views to make data comprehensible. So you have some very complex data. What you can do is you create views and simplify it to whoever you're trying to give the data to. Let's see here. The data structures in a database will be normalized tables. It is not reasonable to expect users to understand normalized structures. To take an example from Oracle e-Business Suite, okay, let's only get that out. I would end right there. Yep. So guys, in other words, views, when I say views to take or to make data comprehensible, right? You have like the data dictionary, the Oracle data dictionary based tables are very, very complex. So Oracle created views with them. So that thing that we're talking about, DBA object, user underscore object, those are all views, as a matter of fact, meant to simplify querying the data dictionary for us. What about views for performance? What is that? This section, you'll read this when you have time. But for now, just get the overall picture of this, guys. It says the select statement behind a view can be optimized by programmers so that users don't need to worry about running code. There may be many possibilities for getting the same result, but some techniques can be much slower than others. For example, when joining two tables, so let's see here, guys. When joining two tables, there is always a choice between nested loop join and hash join. So guys, what's some words that you can just grasp from now? So there is a loop called a nested loop. This one called a hash join. And I think here they define both of them, which is one of the few places in the book that they talk about those. So what is a nested loop join? So let's see what. So the nested loop join uses an index to get to individual rows. Then a hash, another one, a hash join. Let's see what that one does. Reads the whole table into memory. The choice between the two will be dependent on the state of the data and the hardware resources. That's true. So let's read the last paragraph there, which seems to be my conclusion here. It says, theoretically, you can always rely on the Oracle optimizer to work out the best way to run a SQL statement. But there are cases where the optimizer goes wrong. So the big thing here, guys, I hope you all remember, we had seen this thing here called the Oracle optimizer before. We saw that somewhere. I would just move forward. Simple and complex views. Okay, this one is a little bit more important. So I'll put a star here. When you get here, guys, do me a favor and read this section. Let me see a few things. We'll talk about it, and then we can leave. Simple and complex views. Therefore, there are different types of views, believe it or not. Different types of views. So here, if you have your book with you, right, let's just make a note here, like types of views. And for this type of views, so there's a view called a simple view. And it's a view called a complex view. Then as we go down the line, there's going to be a third type of view called materialized view. Material.
I'll call
Nice.
you right back.
View.
Yeah, I'll call you
So
right
that
back.
one
I'm almost done
will
with
be
my
the
class.
third type of view. The three main types of views, guys, that we're going to see. So there's simple view, complex views, and materialized views. And the difference between materialized views with this one is that materialized views store data in segments. If you're writing anything, maybe I want to put that here. So this one, they store data. In segment. You know what a segment is? And materialized views are used for data replication. Take me those tiny little notes, they're just a materialized view. Then we may see this towards the end of the course. What is a complex view? Guys, what is a complex view? I think that's all. By default, regular views are just, they're simple views, okay? For practical purposes, classification of a view as simple or complex is related to DML. So guys, that is related to DML. Statements can be executed. Let me see. Oh, it depends whether DML statements can be executed against it. So guys, that's the whole thing. Simple views can usually accept DML statements. Let me see the next line. Complex views cannot. The strict definitions are this. So guys, yep, so this is the crux of it here. A simple view, a complex view. So all that stuff up there will wind up with this one here. What is a simple view? A simple view draws. So that one, guys, draws data from one detailed table, uses no functions, and does no aggregation. That's what it is, guys. A simple view is a view with a very simple SQL statement. That's all it is. Whereas a complex view can join detailed tables. Then, guys, this one, it uses functions and performs aggregations. What are aggregations? Hey, can somebody tell us what aggregations are? What are aggregations? I mean that word right there. Aggregation.
I think it's like putting items together, something like that.
That's true. It's like putting items together. Things that you've put together. Separate things brought together. So a complex view, in other words, they say can join detailed tables. Means a complex view will have more than one table that is pulling the data from. They can be using functions and even using aggregation. Good. Any question about simple and complex view before we move on? Any question there? No question. So I am happy. Applying this definition shows that the four views used as examples in the preceding section, the first and the third are simple, and the second and fourth are complex views. Okay. Don't even, let me take that off. Don't need to highlight that. Instead, this one need to highlight. it is not possible to execute insert, update, delete commands against a complex view. Woohoo! That's a typical interview thing. I've seen that on some Oracle questions. Okay. The mapping of rows in the views back to the rows in the detailed tables cannot always be established. Okay, that's just an explanation of that, which I am not going to go through. When you guys read it, you can go through that. Cool. Let me see if there's anything of importance here, of importance. All right, I won't look at anything there again. Let's move on to the next section. Okay, next section is done. Forget that. Now let's just see how to create views, and then you guys can go. I don't have the senior class today, so that's why I'm doing this, okay? But the senior guys, if those of you who are still online, we could talk later, but there's no official class. Because you all are working on something. So, hey guys, this is create a view. You simply do it like this. Create or replace. I like that too. I always join those together. Create or replace view, and you can make it force, no force, to choose any of those. Then view. Create or replace view. Okay, these go together. Okay. Then it gives you a schema, like if you see down here. Schema.view name. Then you can give an alias if you want to. Then you say as. You put your query. Then after you put your query, you can choose to do the next things below, which are with check option. You could do with check option, or you could do with read only. The explanations are down here. But normally we don't go that far, guys, making that whole thing. So if you look at that syntax up there, what does it mean by create or replace? That word or replace. That one simply means this, guys. If the view already exists, it will be dropped before being recreated, and no error will be given. Then what about force or no force? You see here that the force keyword used there will create the new view if the detailed table in the subquery do not exist. So guys, you're creating the view, right, on some table, but the table doesn't really exist. Normally, you have a failure and you tell that that view cannot be created because that table is not there. But if you decide to use force, that view will be created even if the table doesn't exist. No force is the default. Okay, good. Then what about with check option? When you put with check option when creating a view, what does that do for us? This has to do with DML. That's data manipulation language. If the subquery includes a where clause, then this option will prevent insertion of rows that wouldn't be seen in the view or updates that would cause a row to disappear. Okay, don't worry about that. Hold on, we'll never use it for anything. So there is that guy, there is with read only. So with read only, this prevents DML through the view. So you cannot write a query through that view if you're not given the proper permission, or it is not made back to read or to read write. Constraint option. Okay, let me just skip the rest. We don't need to know the rest. Let's go down. And I want to do, okay, I'll end right there. So guys, I want you guys to do these exercises. Please, please, we're using these tables in the HR schema. And the HR schema, for your information, is only on the 11G database. 12 does not have the HR schema. but we're going to create it there later. Okay. Good. Let's end right there. And what's a synonym? All you need to know about synonym is this: an alternative. A synonym is nothing but an alternative name for an object. That's it. And how do you create a synonym? Very simple. Let me just go to it. You create a synonym like this. Create public synonym. There are two types of synonyms, public and private. So if you don't want to use public, private synonym means this: only you who create it can see it, okay? But public, anybody can see it. So create public synonym EMP4, and you give your table name, and you end that bad boy with a semicolon, and then that's it. The only thing that makes it a little bit complex is doing it public or private. All right, but that's it on that one. So guys, I want you guys to read this, do the exercises if you could, and then look at synonyms, and I think there's an exercise for synonym. You do that. Only doing the exercises would you be able to understand this thing. So guys, through this class, I know you're sleeping. For where I would also be falling asleep listening to somebody read all night long. And I'm sure if we vote, some people may say, let's do exercises more than read the book, and you guys read. That's what I want you guys to do from today. Everybody read that book for me. Then we could help do those exercises and other examples that I have. With that said, let's call it up for the night. Yes, Stanley, let's make it quick for today.
Okay, sir.
Okay. Good night, guys.
Okay,
Yeah,
sir.
good night. Good night.
Good night, Prof.
Yes, good night. Good night, guys. You guys take a rest. Do some hands-on. Thursday we'll do more hands-on than reading.